All right, today we're going to dive into a pretty delightful game, and it was invented by a mind you would probably never expect to find in the world of formal logic.
I mean, it seems like a really odd pairing, doesn't it? On one hand, you've got this world of pure whimsical fantasy, talking rabbits and mad tea parties. And on the other, you have the world of super rigorous, structured, and, let's be honest, sometimes pretty intimidating reasoning.
That's right, the very same man who sent Alice tumbling down that rabbit hole was also a mathematician and a logician at Oxford University, and he was on a mission. He wanted to rescue logic from its dusty, old academic reputation.
This is really how Carroll saw logic, not as some dry set of rules, but as this powerful, beautiful tool that had been trapped, basically gagged and bound, needing to be set free. And his solution was just brilliant in its simplicity. He decided to turn it into a game. So how does this game actually work?
Okay, so first, to really get the game, we need to understand the problem that Carroll was trying to solve. What even is logic, really, when you strip it all down?
At its heart, logic is all about these things called propositions, and they're just sentences that make a claim. Sentences like, all new cakes are nice, or no dragons are friendly, or some politicians are honest. The whole point of logic is to test whether these statements and the conclusions we pull from them are actually valid.
He had this big aha moment where he realized the problem wasn't the ideas themselves, it was the abstract language we use to talk about them. So he set out to transform these abstract words into a visual, physical game board, making logic something you could literally touch and play with. Let's see exactly how he built it.
So, how'd he do it? He started by creating a simple, organized space to sort all the ideas within a given topic, or what he very charmingly called a universe. Carroll called his game board a cupboard, and I want you to just picture this. A big, empty cupboard that's designed to hold all the cakes in the entire world. First, we just slice it in half, horizontally. New cakes go on top, not new cakes go on the bottom. Then we slice it again, but this time vertically. Nice cakes on the left, not nice on the right.
And what you get is the simple little grid with 4 quadrants, and each square now represents a very, very specific kind of cake. That top left corner, that's for cakes that are both new and nice. The bottom right, well, that's for cakes that are not new and not nice. See, every single possibility has its own little home.
All right, so now we've got our board, our cupboard for ideas. Every good game needs pieces, right? Well, Carroll kept it incredibly simple, using just a couple of colored counters to bring all those abstract propositions to life.
And the rules are just beautifully straightforward. A red counter means some, as in at least one thing exists in that category. It shows the square is occupied. A gray counter means none exist. It shows the square is completely empty. That's it. Let's see it in action.
Okay, let's try one together. This proposition is stating that in our universe of cakes, there's at least one cake that is both new and nice. So how would we show that on the board?
Well, we find the square for cakes that are new and nice. That's the top left one, and we just place our red counter right in it. This shows that this little compartment is occupied. Simple. That abstract sentence is now a concrete reality on our board.
Okay, what about a negative proposition? This one makes a totally different claim. It says there are absolutely 0 cakes in existence that are both new and nice. So we just go to that same new and nice square, and this time we place a gray counter there. This is our signal that that category is completely empty.
Now for the really, really clever part, how Carroll handles a universal statement like all. See, he saw it not as one statement, but as 2 statements combined into one.
Think about it. To say all new cakes are nice is to say 2 things. First, some new cakes are nice, so we put a red counter in the new and nice square. And second, you're also saying no new cakes are not nice, so we put a gray counter in the new and not nice square. This combination is what makes the whole thing visible. You can see at a glance that the only place a new cake can possibly exist is in the nice category. And this is where the game gets truly powerful. It's not just about representing single sentences. We can use it to solve these logical puzzles called syllogisms, where you take 2 true statements and use them to find a third. This lets us discover new truths that we couldn't see before. So let's use one of Carroll's own quirky examples. To solve this, we're going to need a slightly larger 8-square board to handle a third attribute, in this case, canny or uncanny. But the principle is exactly the same. Let's place the counters for our 2 premises and see what the board tells us. Okay,
So here's the board after we've mapped our two premises. Placing the counters for all dragons are uncanny eliminates any canny dragons, and placing the counters for all Scotchmen are canny eliminates any uncanny Scotchmen. But wait, look at what just happened in the process. A gray counter landed in the square for things that are both dragons and Scotchmen. That compartment is now marked as totally empty.
And there it is. The board has visually proven the conclusion for us. By just placing the information from our premises, we can simply read the result. The categories of dragon and Scotchman cannot overlap. There are no things that are both.
So, it's a clever game for sure. But why should we care about this quirky 19th century invention today? What's the real takeaway here?
This is the powerful underlying lesson. The game isn't just about cakes or dragons. It's a method for thinking clearly. It teaches us a timeless skill, how to take a confusing argument, break it down into its core components, visualize how those parts relate to each other, and see the logical connections for ourselves.
Carroll's game shows that turning abstract problems into concrete, visual systems can reveal solutions that were hiding in plain sight. Think about untangling project dependencies at work, or maybe mapping out the pros and cons of a major life decision. Maybe the best way to solve it is to build a little cupboard for your ideas. It's a lesson that is just as useful today as it was back in Wonderland.